Good afternoon, children. All of you, welcome back to our online class. How are you all? It's the first time we are meeting after your Onam holidays. How was your Onam? Did all of you enjoy? Okay, we know that we have a different kind of Onam in this year. So, we celebrated our Onam virtually, and I wish we will have a better Onam in the next year. Okay. Then, children, in this class, we are going to start a new lesson from physical science. Okay, that is the chapter 4 materials, metals, and non-metals. It is a chapter materials, metals, and non-metals. Okay, and in this chapter, the topic to be covered are the main topics are what are metals? What are the examples of metals? And then physical properties of metals and non-metals. Then chemical properties of metals and non-metals. The chemical properties of metals and non-metals include the reaction with oxygen. What do you mean by the reaction with oxygen? It means what happens when a metal reacts with the oxygen. What happens when a non-metal react with the oxygen. That is mean by the reaction with oxygen. And then reaction with the water. That means what happens when a metal or non-metal react with the water. And the next reaction with acids, reaction with bases, and it also includes displacement reaction. And also this chapter include uses of metals and non-metals. Also uses of metals and non-metals. These are the main topics that are to be covered in this chapter. Which chapter? Materials, metals and non-metals. Okay. Then I know most of you, only at least one or two students will think that why we should study about metals and non-metals, isn't it? How many of you think like that? Okay, some of you will think that how should we study? Why should we study about metals and non-metals? And also, why should we spend this much of time for studying about metals and non-metals and their properties? Isn't it? Okay, then all of you listen here. It is because to know about that, first we can look into different substances that are we are using in our day-to-day life and also that are made of metals. Okay, let's see some examples. Okay, the first I would like to say about what will be. Have you any guess? Jewelry. Okay, you are familiar with jewelry, which include earrings, chains, or rings. Okay, most of you are familiar with jewelry, and also many of you use jewelry, or you see that your mom or sisters wearing different kinds of jewelry items. And we know that the jewelries are made of which one? Mainly gold, platinum, or silver. And we know that these all are metals, isn't it? These all are metals. The next one is, which is one hammer. We usually use this hammer for fixing nail and also fixing photographs or like that. Also for mainly for fixing like for such kind of things we usually use hammers. And this hammer also has a metallic part. Isn't it? This hammer also has a metallic part. And next I would like to say about iron nail. we know that the tiny iron nail, which is also made of iron, and iron is an example for metal. We know that this iron is used for mainly these irons are used in making furnishing items or other things, or for connecting things. For such a kind of activities we usually use iron nails. And the next is, it's what is this? Fencing wires. We usually see that people often use fencing wires for covering the yards, isn't it? Or our garden, mainly for protection. And this fencing wire is also made of metal. Okay? Not only this fencing wire, we know that the fencing wire is for protecting our field. Not only these fencing wires, also we usually see that the refrigerators as most of the part is made by using metal. It's a metallic part. Okay. And not only these fencing wires, also the gun used by the policemen for our protection is also has a metallic part. And also vehicles, cars, bicycles, motorbike, etc. all has metallic part. That means the metal has an extremely important role in our day-to-day life. The metals has an extremely important role in day-to-day life. Most of the things that we are used in our day-to-day life are made of metals, or metals are used in most of the useful items that mainly use in our day-to-day life. So, due to this, we have to be aware of the properties of metals. Okay? So, we are going to learn about physical properties of metals and non-metals. First, we are going to learn about physical properties of metals and non-metals. For studying the physical properties of metals and non-metals, first I would like to see some pictures of metals and non-metals. Okay, all of you listen carefully to the pictures. Okay, and also give answers to my questions. It's very simple questions. First, what is this? Yeah, it's iron nail. We know that it is made of iron and it's an example for metal, say metal. So you have to say the appearance of this iron. How is the appearance of this iron? Yeah, it is very shiny. And what about the hardness of this iron? Yes, it is very hard. Okay? Okay, children. After listening to this video class, you have to take your textbook and fill the table 4.1. Okay, fill the table 4.1. Okay, then we know that it's iron nail. Iron nail is, what about the appearance of iron nail? It is very shiny in appearance, isn't it? Shiny in appearance, and also it is very hard. And what about the hardness? It is very hard. Then, next is, what is it? It's cold. It is cold. Then, what about the appearance of this coal? Is it shiny? No, it is dull. It is dull in appearance. And what about the hardness of this coal? Is this hard, that much of iron? No, it is not hard. It is not that much of hard. Then, the next is, do you know what is this? It's sulfur. Okay. What about the appearance of sulfur? The sulfur is also dull in appearance. Then what about the hardness? It is not very hard. Here, first we consider about iron nail. And iron is an example for Metal or non-metal? Iron is an example for metal. So that is very hard and also it is very shiny in appearance. Next, we looked about coal and sulfur. Both coal and sulfur are dull in appearance and also it is not very hard. Okay. Then, next look. Can you say what is this? It's aluminium rod, mainly aluminium rod. That's mainly we are used to for aluminium fabrications and also for hanging curtains, etc. What about this appearance of this aluminium? Yes, this aluminium is very shiny in appearance. Okay, very shiny. What about the hardness of aluminium? It is very hard. It is very hard. And also the aluminium is an example for metal. What is the next one? It is copper wire. Is this copper wire? What about the appearance of this copper wire? Yes, this copper wire is also very shiny in appearance. And also, what about the hardness? It is very hard. It is very hard and strong. Okay, by comparing these things, we looked about 5 substances. From this, iron, aluminium and copper. These three are examples for which one? Metal or non-metal? Metal. And what are the common properties of these three? Yes, these three are, that is aluminium, iron and copper are very strong, very hard and also it is shiny in appearance. And the shiny in appearance is called as luster. If a substance looks very shiny, then we can say it as luster. Its property as luster. It has a luster property. So, aluminium, iron and copper has luster property. Okay, and these three are examples of metal. So, generally we can say that the metal has luster and it is very hard. Then what about the other two? What are the other two? Sulfur and coal. Sulfur and coal. These two are examples of which one? Non-metals. And which is dull in appearance. Which is dull in appearance and it is not strong. It is not very hard. Okay. From this we understood that the metals are luster. That means shiny in appearance and it is very hard. Okay. These are some physical properties of metals and non-metals. Then look another one. For understanding some another physical properties of metals, all of you listen here. I will show you a activity. Okay. All of you carefully listen this experiment.
For this activity, we need a small iron nail, a piece of coal, a pencil lead, a piece of thick aluminium wire and a hammer. To start with, beat the iron nail with a hammer. Hit the nail hard. You have to do it carefully. Take care so that your hands do not get hurt. Now hit the aluminium wire hard. This time also take care of your hand. What do you see? Is there any change in?
What do you have observed here? Yes, first we take one iron nail and aluminium rod. Then it is beaten with a hammer. What happens here? Is there any change in the shape? Yes, there is a change in, you can see here, there is a change in shape in iron nail and also in aluminium rod. The beaten end become flattened, isn't it? Okay.
The shape of nail and wire? You can see that the shape of the iron nail and the aluminium wire changed on beating. When they are beaten harder, the iron nail and the aluminium wire take the shape of thin sheets or they are flattened. Now hit hard the gold piece and pencil lead with the hammer. Interestingly, you will find that gold pieces and pencil lead break into small pieces on beating. It is the property of the metals that they take the shape of a thin sheet on being hammered. This property of the metals is known as malleability. This is a characteristic property of metals.
Okay. What do you have understand from this activity? Yes, here first we take one iron rod, iron nail and aluminium rod. Then we beat with a hammer. We see that there is a change in shape. To which one? Iron nail and aluminium rod. Both become flattened by beating with a hammer. Then what is the next? Next we take one cold piece. And which one? Pencil lead. Pencil lead. Then also we repeat that experiment, repeat that activity. What happens there? The both pencil lead and also the coal piece become small, broken down into small pieces. It is not become flat.
This is a characteristic property of metals. As you saw in the experiment, materials like coal and pencil lead do not show this property as they are not metals. In this module, you have learned that metals form thin sheets on hammering. The property of metals by which they can be beaten to form the flattened or thin sheets is called malleability.
Yes, from this activity, we understood that the metal form thin sheet on hammering, and this property of metals is known as malleability. Okay, what do you have understand from this activity? Yes, you saw that the shape of the iron nail and aluminium wire changed on beating. We say that the shape of iron nail and aluminium wire changed on beating. If they were beaten harder, these could be changed into sheet. By applying or by beating harder, we can make these metals into thin sheet. And this property is called malleability. Okay, property of metals by which property of metals by which they can be beaten into thin sheet is called malleability. Here we saw that the shape of iron nail and aluminium wire changed by beating with this hammer. And if they were beaten harder, this become thin sheet. And the property of these metals by which they can be beaten into thin sheet is called malleability. What is called malleability? The property of metals by which they can be beaten into thin sheets is called malleability. This is a characteristics property of metals. Malleability is a characteristic property of metals. As you must have noticed, materials like coal and pencil lead do not show this property. What do you mean by that? That means the pencil lead and coal are not examples for metals. They all are non-metals. Pencil lead and coal are examples for non-metals. Okay? What is me? Here we learned about three properties of metal. The first one is luster. It is very shiny in appearance and it is very hard. And the third is malleability. The physical property of metal is malleability. And next, can you hold a hot metallic pan which is without a plastic or wooden handle? Can you hold a hot metallic pan with your bare hand? No, because the heat will be transferred into our body. It will cause burn in our body. That means the metals are good conductors of heat. The metals are good conductors of heat, which is another property of metal. Which metals are good conductors of heat. Okay. Here we are doing another activity. Here we make a circuit like this. Okay. Here we make a circuit like this. We use a battery and a bulb. These are the connecting wires. Here we use a which one? Iron nail. Then by connecting this circuit, we can see that the bulb glows. Okay. Then we replace this iron by a copper wire. We remove the iron nail and connecting a copper wire in the place of this iron nail. That time also we can see that the bulb glows. Next, we replace that copper wire by using a coal piece. That time did the bulb glows? No, it does not glow because the coal is an example for non-metal and it does not conduct, it does not allow the passage of electricity through this. And also we remove that coal piece and we connect a sulfur in this place and repeating this activity. Here also the bulb does not glow. That means the coal and sulfur are examples of non-metals. Then what about the property of that non-metals? The non-metals usually does not allow the passage of electricity. Is it clear? We know that from here we can observe that the iron rod and iron rod, nail and copper wire are good conductors of electricity. So the bulb glows. And if we replace a sulfur piece or coal piece, the bulb does not glow. That means they are poor conductors of electricity. That means the metals are good conductors of heat and electricity, while the non-metals are poor conductors of heat and electricity. Okay? Then what are the topics? What are the properties of metals? We learn here. The metals are lustrous. Lustrous in nature. That means they are shiny in appearance and also they are very hard. Then what is next? It is malleability. We can make the thin sheet. That is they are malleable in nature. And what is the next? It is good conductors of metals are good conductors of heat and electricity. While the non-metals are poor conductors of heat and electricity. Okay? Okay. Then I will show some pictures for studying some more properties of metals and non-metals. Okay? Here, what are the two things? It's copper, Cu, copper, and it is aluminium. We can see that it is seen as wires. It is seen as wires. That is, the metals can be made into thin wires. The metals can be made into thin wires. The property of metals by which it can be drawn into thin wires is called ductility. What is called ductility? The property of metal by which it can be drawn into thin wires, which is called ductility, which is another physical property of metals. And the next one is sonority. We usually use brass. It is an example for metals. And also we see that the school bells are made of metals. That is, the metal has a capacity to produce sound, good sound, by beating with some wooden piece or the hammer like this. That is, the metal has a ability to produce sound when struck, and which is called sonority. What is called sonority? Sonority is the ability to produce a sound when struck. The metals are sonorous. The metal has the ability to produce sound when struck. So, it is called sonorous. Metals are sonorous. We know that the metals are malleable in nature and it is ductile in nature and also it is sonorous. That is, they produce a specific sound when struck with a hard object. What are the properties of metals? The metals are ductile in nature. What is meant by ductility? We can make the thin sheet which is called ductility. The property thin wires. The properties of metal by which it can be drawn into wires which is called ductility. What is called malleability? The property of metals by which it can be drawn into thin sheet which is called malleability. What is called ductility? The property of metals by which it can be drawn into thin wires. Thin wires is called ductility. The next we learned about sonority. What is called sonority? Metals are sonorous. That means they can produce a specific sound by beating when we struck, and it is called sonority. These are the important physical properties of metals. What are the important physical properties of metals? They are very hard in nature and also it is shiny in appearance. That is called luster. And also it is malleable in nature and it is ductile. The metals are malleable, metals are ductile, it is sonorous and also they are good conductors of heat and electricity. And we see that some materials are hard, lustrous, malleable, ductile, sonorous and good conductors of heat and electricity. Some materials are hard, lustrous, malleable, ductile, sonorous and good conductors of heat and electricity. Such materials are called metals. The materials which generally possess these properties. Which properties? They are hard, lustrous, malleable, ductile, sonorous and are good conductors of heat and electricity. Then they are called metals. And can you see some examples of metals? The examples of metals are iron, copper, aluminium, calcium, magnesium, etc. are examples of metals. Which are the examples of metals? Iron, copper, aluminium, calcium. These are some examples of metals. In contrast, materials like copper and sulfur are soft in nature and also dull in appearance. It is soft in nature and also dull in appearance. And they break down into a powdery mass on tapping with a hammer. And they are not sonorous. They cannot produce sound by tapping with it. And they are poor conductors of heat and electricity. and these materials are called non-metals. If some metals they break down into number of pieces by tapping with hammer, and they are not sonorous, and also they are poor conductors of heat and electricity. Then it is called non-metals. These are the characteristics of non-metals. Okay. Then can you see some examples for non-metals? We see that the sulfur, carbon, oxygen, phosphorus, etc. are examples of non-metals. Okay. Here, there is some exceptional case in metals. Here, metals like sodium and potassium. We know that sodium and potassium is an example for metal. It's an example for metal. But they are soft. But it is soft in nature. It's an exceptional case in metals. Which are the one? Sodium and potassium. Sodium and potassium are metals, but they are soft in nature, and also it can be cut with a knife. It can be cut with a knife. It is exceptional case in metals. And also mercury. Mercury is the only metal which is found in liquid state. Which is the only metal which is found in liquid state. Mercury. ECLA that the iron, aluminium, copper, etc. are examples of metal. But they all are existing nature as solid state. But here one metal, which is the metal mercury. The mercury is an exceptional case of metal which is existed in liquid state. Which is the metal that exists in liquid state? Mercury. And these are the exceptions. Okay. Generally the metals are hard in nature and lustrous, malleable, etc. But there is some exceptional case like sodium and potassium. They are metals, but it is very soft in nature and we can cut them into pieces by using a knife. And also we know that all the metals are solid in state, but there is some exception. That one is mercury. Mercury is existed in as which state? Liquid state. Okay. These are the main things. Okay. So today we learned about what are metals, what are non-metals, what are some examples of metals and also examples of non-metals, and physical properties of metals and non-metals. Okay. All of you, please read your textbook thoroughly today itself, and also don't forget to fill the table for point 1. Okay. Anyway, thank you. Have a nice day.